Okay, LeetCode 53, maximum subarray. Funny thing about this problem, when I did it, I could have sworn it wasn't easy, and then I checked back on grind 75, and here it is marked as an easy. So I think at some point when I did it, and then when till today, I think it got updated to a LeetCode medium, which I think is a pretty good call because as we're about to jump into it, you'll see that the solution isn't like super obvious, like right away, and you might kind of feel bad, but you shouldn't because you'll see anyways. So right away, for the brute force solution, I just want to give it a shout out. If you optimize it, you basically go through every index and you keep like checking every possible subarray and you keep like a running sum going and you update that as you go. That's going to result in double for loops with an n squared runtime complexity. But I don't think we should bother with it. And if you ever pull this up in an interview, they're just going to say, can you do better? So let's just go on to the best approach right away. So here I drew something out. And what we're going to do is we're going to use a subset of dynamic programming, I guess, called Cadon's algorithm. I think I'm pronouncing that right. I don't know. And we're going to keep two running tallies. So we're going to initialize a variable called the current sum. So that's the current sum we encounter. So let's just set that to 0. And we're also going to set the maximum sum. And that's going to be, let's say we'll just make it equal to the first value in our nums array. So we'll say -2. And basically, what we're going to do every single time is we're going to ask ourselves a question. So let's say we're at this 2, right? So we're going to say, cool, our current sum is -2. So let me mark that down. We'll say -2. But then I go over to the 1. All right, so my little pointer here is going to move over to the 1. And we're going to sum that up, right? -2 plus 1 is going to equal to -1. But we ask ourselves, well, first of all, we ask ourselves, is that bigger? Is that our maximum sum? Is that the maximum that we can do? Right? And it turns out -1 is bigger than -2. So we can't update our maximum sum. But before that, what we want to do is we want to ask ourselves, what's bigger? Taking the 1 alone or taking -2 and adding 1? Well, obviously, if we take -2 and we add 1, that's going to give us -1. But if we just take the 1, that's just going to give us a 1. That's bigger than -1. So our current sum now should just immediately reset. We should say, okay, no more -2. We're just going to roll with the 1, right? And then I do the same thing. I move it over to -3. I know that 1 and -3. Oh, sorry. Let's take a step back just for a second. Let's go back to the 1, right? Because since we did take the 1, we want to update our maximum sum because we see that 1 is bigger than -2, and we want to make that a 1. Almost forgot that. All right, we're going forward. We're going to go to -3, and we're going to see, okay, -3 plus 1 gives me -2, right? But then also at the same time, -3 at the same time is less than 1. So I should just suck it up and take this into my current sum consideration. Because remember, a subarray has to be contiguous. So I can't skip it. So I'm going to suck it up. I'm going to take this sum. So I'm going to do 1 plus -3 is going to be -2. Now, obviously, the maximum sum doesn't get updated because -2 is less than 1. And I'm going to go here. And now I'm going to encounter a 4. Well, what's 4 going to give me? I can add 4 to my -2 and get a 2. But I can then take the 2 and I can compare it to 4 alone. And what's bigger, 2 or 4? Obviously, 4 is bigger. So let's reset our current sum back to 4, right? We want to just include 4. So our sum is now restarted. So we have 4. We now move to -1 and we say, okay, -1 is less than 4, right? But we're just going to suck it up and take it because -1 alone is not bigger than 4 plus -1, right? Because 4 plus -1 is just going to be 3. So we're going to suck it up for now, take the 3. We're going to move on to the 2, and we're going to do the same thing again. 3 plus 2 is 5. So, right, so that's our current sum. We take the 2. But what if we want to consider not taking our previous sum with us and restarting? Is 2 bigger than 3 plus 2? No, it's not. 5 is bigger. So we take the 2 with us. So that becomes a 5, right? Then we have the 1. We ask the same question. Do we take the 1 alone, or do we take it, add it on to our current sum? Of course, that's 6. That's bigger than 1. We do that, right? And I keep forgetting to update my max sum. Obviously, this should go without saying. Every time you should be updating your max sum. We'll see that in the code. I'm just kind of dumb right now. Okay, let's see. So we have -5, right? -5 is smaller than our previous value, right? So we're just gonna sum it. We're gonna suck it up and take it for now. So we're gonna do 6 minus 5 is 1, right? So our current sum now becomes a 1. So our max sum doesn't get updated because 6 is still the biggest sum we've encountered. And then we go here. We go move on to 4. What's bigger, 4 plus 1 or just the 4? 4 plus 1 is bigger. That's 5. So our current sum becomes a 5, but 5 is still less than 6, right? So this doesn't get updated. Yeah, so this is actually really short code. This is a really, really short problem. It's just you have to know this trick. I kind of feel it's unfair in an interview. But what we're going to do, so we're going to say int, let's say res for result. We're going to make that equal to nums of 0, like we talked about. We'll say int current sum is going to equal to 0. So we're going to keep that rolling sum going. And we're going to do 4. I'm going to say integer. I'll pass it in by reference. Integer n in nums. So we'll go through. And then we'll just say, okay, current sum is going to equal to the maximum between, remember, we're going to either take the current sum and take n with us, right? The current number, we're going to take it with us, or we're just going to take the number alone and restart our tally, right? So we do that. And then, of course, what I failed to do in that picture, we have to do. So we're going to say result is going to equal to the maximum between the already existing result that we have and the current sum that we just created. And at the end of the day, all we do is we return the result. There we go. So run the code, see if it goes. There we go. Example test cases. It runs. Cool. Let's submit it. There we go. A little slow, I guess. The runtime is random as always, but here you go. It runs. That's the most optimal solution, right? Let's look at the runtime. Runtime is going to be linear, right? Because you're only looping through this numbers array once. You're never going back. You're never doing anything else. Space complexity is constant, right? It's O of 1 because no matter how big my nums array is, right? It could be like 10,000 in length. I'm only ever creating these two integers right here, right? So the space I reserve in my memory is the size of 2 integers. And that's pretty much it. Yeah, I don't really like this problem. I feel like to get the optimal solution, which a lot of companies sometimes want, you need to do a lot of memorization. I think that the story goes is like researchers are trying to get this method figured out for years, and this guy, Kudan or whatever, he figured this out in an interview. So it kind of implies that companies are looking for the next Kudan in their interview process. It's weird. I don't know if it's true or not, but there it is. That's all there is to it. I hope this helped. Thank you.